Okay, good day friends. Today, let's try to solve this problem. A cardboard strip folded into the shape of the letter U is placed on an inclined plane, as shown in the figure. At what angle, alpha, that is alpha, of inclination of the plane to the horizontal will it turn over? So here we have this angle alpha, as you can see. We have this kind of long paper, let's call it paper, yep? It's something very thin, like a paper. But we have folded it into three sides, equal sides. Each of the sides are A, and above we have also the same distance. So these are just three cubes, squares, I'm sorry, not cubes. This is not three-dimensional, right? And each of them have mass m. Those masses are equal. So from side it would look something like this, yeah? So this is one of our sides. Here we have another side which is folded, and here the last side is this one. Okay, I hope that you can imagine it, but let's try to solve it. Let's try to first draw it, so it was even more understandable to you. I would draw it from the side. We have here angle of A with of alpha. Let me write it down here so it was understandable to you. And I would draw it something like this, okay? Yeah, it's not perfect, but I hope it's understandable. What we have here, as you can see, we have this side, and again this side, but from the other side, which is, yeah, right now this blue one is this one, this side. But also behind that blue part, also we have this thing. This thing, oops, this part, yeah, this is a red one, is also hidden behind this blue one, yeah, right? Let me so draw it something like this. What about the third side? Let me draw it with, I don't know, green maybe. This part, what happened to this one? Yeah, something behind. What happened to this? The thing is that it is totally in this face, which is not visible to us right now. But I hope that you can imagine it. Okay, why am I working with it like this? The thing is, right now you can notice that here we have from the center of mass of both blue and red, they are exactly like the simple mass, yeah, the simple weight, the same direction, yeah, mg. What about this green part? In fact, its center of mass is on its center, but its center is here, not here, right? That's why the last weight must look something like this. This green one must be somewhere here. Here it has a mass as well. Okay, and also right now we can divide it into components. Yeah, let me divide components of the blue with pink. It would be something like this. Here we have 2 mg. This is important. Why? Because we have this closer side, which is blue one, and the farther side, which is red one. And we have two masses, two center of masses on the same axis. Okay, so this thing has to be just as usual 2 mg cosine alpha. I hope that I don't have to explain why this is cosine, why that is sine alpha. This thing 2 mg sine alpha, right? The very same principle goes here. Let me write down it with orange, I believe. It would be, yeah, it would look something like this and like this. This thing has to be just mg cosine alpha, the same alpha, the same angle. They're on the same inclination. This is mg sine alpha. Okay, good. And right now, we don't have to think much. If we just imagine this case, at what angle of inclination of the plane to the horizontal will it turn over? We know that if it turns over, first this part will get attached and then it will roll like this, right? So we don't have to think where we should put pivot. In fact, we can put it anywhere, but in our case, it would look something like this. Our pivot would look like this. This part would split away from our inclined plane, and then this thing would turn over like this. Yeah, it cannot turn over that side because the gravity, as you can see, its components look the opposite side. Okay, good. And okay, if this thing starts to rotate, of course we could have right here the normal force that is pushing this thing upward, but right now we cannot do it. Why? Because as it starts to turn over, it breaks away from the inclined plane. That's why there would be no more any normal force. Mg cosine alpha, 2 mg cosine alpha, they would still exist. That would not be a problem. Okay, so what we have here, what are the forces? We have here the length of A, here as well, and definitely if this thing tries to turn over, yeah, then there are some torques like this. And there is one more torque, which is here, yeah. In fact, here we have two torques, yeah. This 2 mg sine alpha is trying to rotate like this, T1, torque 1, and also torque 2 is also this thing, mg sine alpha itself. But the problem is that we can write it as 3 mg sine alpha. They are looking all in the same direction, and they are trying to rotate the same direction, right? And some people might say that this distance, this distance is different, and this distance is different. But the problem is, in fact, we are not interested in that distances, because we're working here, not with distances, but but the forces, right? In fact, this vector of the force could look totally like this one. For example, let me take a different color, maybe yellow one. It could look like this. and they're passing from the same side. So this thing would be 3 mg sine alpha. That would not be the problem. I can write it as this is 1 torque. That's why let's write it here, torque 1. And here we have torque 2. Okay, good. And right now what we are going to do is something like this. Sum of torques equals to 0. We know that thing because it is in equilibrium still. Torque 1 has to be equal to torque 2. Yeah, because this thing is not being rotated, it just tries to rotate. Normal force acts no more. Yeah, at last second where it tries to rotate, normal force no longer works. Here, the torque 1, the formula of torque, you definitely know this. This is force and cross product R, which means that these forces has to be perpendicular to that distance. And we have that force 3 mg sine alpha. This would be somewhere here. Yeah, mg 3 sine alpha. Its distance from pivot is just a. And here we have torque 2, which is 2 mg cosine alpha, and it is also a distance. Okay, I'm sorry, not a, but a divided by 2. Yeah, because here this entire part is a, but the force is just in the half of it. This distance is a divided by 2, and also this small distance is a divided by 2 as well. Okay, 2 mg cosine alpha is here. And also the same distance, a divided by 2. As you can see, a is cancelled out, this is cancelled out, and then mg goes out. We can move this cosine to that side, and then you would have sine alpha divided by cosine alpha. Here we would have 2 divided by 3, and sine divided by cosine gives us tangent alpha. This would be still 2 divided by 3, and alpha would be just what? This thing would be arctangent 2 divided by 3, and that would be our answer in this case. Okay, I hope it was pretty understandable to you. When the angle would be something like this, then this thing would start to roll over, turn over, which means that, in fact, from this formula, we can see that masses are not much important, to be honest. Masses don't play a huge role in our case. Yep, the main thing is the angle. Okay, and if it was pretty understandable to you, I'm truly happy, and if you didn't, you can write me privately. Thanks for your attention.